students, welcome to Veteach. Today I am going to discuss with you about binary search. In previous concept, we have learnt about linear search, isn't it? And its drawbacks. Now let us learn about binary search. What are the drawbacks in the linear search? If the element is not there in the array, so unnecessarily it go for comparisons and comparisons. If there are n elements, then it go for n comparisons. Yes, and also if the element is at the nth position, also it go for n comparisons, isn't it? Now in this binary search, we can eliminate those n comparisons. It means that so there will be minimum comparisons will be taken here. So there are maximum comparisons have been taken in the linear search, but in the binary search we can go for minimum type of comparisons. Okay, let us see. So how the binary search works. Here in the binary search, for example, if we are having the array in this way 10, 20, 25, 30 and 45. For example, I am having an array with the following elements 0, 1, 2, 3 and 4. Total how many elements? I am having 5 elements, array of 5. Okay. So, how we have to implement the binary search means we have to consider the first element as low and the last element as high. Okay, it means that a of 0 as low, a of n minus 1 as high. Okay, fine. Now you should calculate the mid value. We should calculate the mid value. How we should calculate? Low plus high by 2, 0 plus 4 by 2. So the mid is 2. For example, I want to search the element 20. I want to search the element 20. Now what here we are doing is we are just first we have to calculate the mid value. Then if the mid is less than, we have to compare these three conditions. You can see here the conditions. Okay. So if the a of mid is less than the target element. Okay. What is the a of mid element here? A of 2 means 25. 25, okay, less than target element. What is the target element I am going to search? 20. Okay, then what we have to do is if 25 is less than 20, so we have to search the elements from 0 to, so we have to go for high equal to mid minus 1. So we have to set the value high as mid minus 1. So what we are doing is we have to split the array into two parts. Okay, we have to split the array into two parts. How we have to split the array? By calculating the mid value. How we calculate? By calculating the lowest position and by taking the n minus 1th position, and we have to calculate the average. Then we get the mid position. So by taking the mid position, we compare whether the 25 target element comparing with the mid element. If the 20 is less than the mid element, so we should take this part. So we should take this part. So what is the left part? 10, 20 and 25 as a first part. So we have to take the left part, only the left part. What is left part means? Taking the mid element, mid left part as a one array and right part of the mid element as a second array. So 10, 20 and 25. So again we have to calculate the mid value. So what we are doing? We are just taking the low 0 as constant in the previous step also. Here we have just modified the high value. What is the high value? Mid minus 1. So 0, 1, 2. Okay. So what will be the mid value here? Mid minus 1 means this is the mid value. So here the mid value. So this part 10, 20 as first left part. Here 25 is the mid value, isn't it? So this is the high. So what we do is, first we have to calculate the mid. So what is the mid here? 0 plus 1 by 2, 0 plus 1 by 2, so some 0.51. Okay, okay. Now what we do here, we have to check whether the A of mid is equal to key element or not. Key means the target element. So what is the A of mid? One element here, 20. Here 20 is equals to 20. Okay, the element is found. So first of all, we have, whenever you calculate the mid value, you should compare whether they both are equal or not. If they both are not equal, then you should go for the next condition. What is the next condition? Whether the target element is less than the mid element, whether the target element is greater than the mid element. So we have to go for three conditions: whether the mid element is equivalent to target element, or whether the target element is less than the mid element, or target element is greater than the mid element. Okay, so according to these conditions, so one condition will be definitely satisfied. So the mid element will be equal. Here the condition which one satisfies, mid is equivalent to key, isn't it? So you can see in this how many comparisons were gone for? Only two comparisons, isn't it? If in the linear search, two comparisons, but here whenever you go for huge elements, the comparisons will be decremented. So maximum comparisons will not be taken here in the binary search. This is what the binary search has a very important, very easiest point, very easy to find out the element. Okay, so this is why, because we go for binary search whenever we having a huge elements. And one thing we have to remember is the elements should be in the sorted order. The elements should be in the sorted order. If the elements are not in sorted order, what we have to do? First of all, we go for sorting method, and then you should go for searching method. So whenever you apply the binary search for an array, first of all you have to check the elements are sorted or not. So whether the elements are sorted, then you can go for binary search method. Then you can apply this technique on the respective array. Okay, so let us see in this program how the conditions have been taken. You can see here start index, end index, and the element. Okay, here start index 0, end index is 4, 20 is the element. Okay, so what I have taken the array, same example. What is the example? You can see 10, 20, 25, 30. Okay, so for example, I am taking one more element, 40. Okay, now I am going to search the element 40. In linear search, how many comparisons will be taken here? 1, 2, 3, 4, 5. I am taking one more element, 5. 1, 2, 3, 4, 5, 6. Okay, total how many elements I have taken? 6 elements I have taken. Okay, fine. In linear search, for this example, for 40 element, how many comparisons will be taken? Just note it down. In linear search, if you want to search for element 40, then how many comparisons? 6 comparisons will be taken. Okay, 6 comparisons will be taken. Okay, fine. Now let us see how the binary search calculates. Okay, so 0, and what will be the index, end index? 0, 1, 2, 3, 4 and 5. Okay, the end index is 5. Okay, now you have to check 0 less than or equals to 5. Yes, so you can see we have to just apply the condition 0 less than 5. Yes, it is true. Now here we have to calculate the mid element. So 0 plus 5 by 2, 2.5. Okay, here we are taking 2.5 mid. You can, whatever the mid value, if you got the point, you should take below index or the upper index, whatever it may be, but you should follow the same method. Okay, just we consider the 2.5, 3 as the mid element. Okay, 3, 2.5 means 3. Okay, now you should, what is the mid value? 2. So according to this, we have to check whether they both are equal or not. What are the elements we have taken? I have said to search. I have said to search the element 40, isn't it? So, okay, what is the mid value? 3. What is the A of 3 element? 25. Is 25 equals to 40? No. Then it goes for one more condition. What is that? A of mid less than the element. So what is the element? 40. What is the A of mid element? 25. 25 is less than 40? Yes, 25 is less than 40. Now what we have to do? We have to change the indexes. Which index we have to change? We have to change the start index as mid plus 1. So what we are going to do here is we are skipping the comparisons, isn't it? So mid plus 1 means, what is the mid plus 1? 3 plus 1. So 4. So the start will be changed as 4. The start will be changed from here 0 to 4. Again while loop means here. So again it checks. What is the start index? 4 less than 5. Yes, it is true. Now again it calculates the mid value. 4 plus a high. What is the high value here? End index here 5. 4 plus 5, 9 by 2. 9 by 2 means 4.5. So 5. So what is the value here? 5. Mid value is 5. Now it checks whether the A of fifth element is equivalent to this element or not. Yes, they both are equal. They both are equal. Then the written mid element will be written. What mid element means? Nothing but mid, not the element, the position. What is the mid here? 5. So the position, the 40 is founded mid. Mid means how much? 2. Founded fifth position. Founded fifth position. See, as I said, in linear search, how many comparisons? If we take the same elements, if you want to search the same element, how many comparisons will be taken? 6 comparisons. So, same input I have taken, but according to binary search, how many comparisons we have done here? Only 2 comparisons. How many? Only 2 comparisons. This is what about binary search. Binary search is used for in order to decrease the time complexity. So the drawbacks of the linear search will be eliminated in the binary search. But you should remember that the elements should be, if you want to give, if you doesn't use the sorting technique in the program, it means that the input should be in the ascending order. Okay, if you doesn't give the elements in the order, whether it are ascending or descending order, then the elements should be go for the sorting technique. So you should also place the sorting technique in your program. So this is what about binary search. Let us meet in the next session with a new topic. Thank you.